Okay, so grade 11s, I've just uploaded your video on basically the first two steps that happen along our nephron. Just trying to keep them a little bit short, so just breaking it down. So we're now at the loop of Henle. And before we get onto the loop of Henle, we need to just quickly be reminded of the structure of the kidney. So if we look quickly at the structure of a kidney, from here I'm going to just quickly draw a quick sketch of the kidney. We have the outer cortex region, and we have this area over here made up of the medulla, the medullary pyramids. So this is the medullary pyramids over here. Okay? And that's a basic structure of the kidney. So this area here is called the cortex, and this area here is called the medulla. Okay? So we've got cortex, we've got medulla, we've got this area here called the renal pelvis. Renal pelvis. Okay? And the renal pelvis connects to this tube here. This is called the ureter. The ureter. The ureter basically transports urine from the kidney, so urine is going to be transported down and get to the bladder. So just reference in terms of what we're looking at. So urine is basically produced by the structure called the nephron. In order to understand that, I'm going to just quickly show you where the nephron is going to be found. So the nephron is found in the cortex. You have that part. We've got a blood supply coming into the glomerulus and exiting. And we have the loop of Henle. Now the cool thing about this loop of Henle is that it actually dips down into the medullary part. Okay? Like that. So that's what a nephron, that structure over here is found in the cortex. There are about 1 million of these in this cortex region. And the loop of Henle part drops down into the medulla. So if you could imagine kind of like a dotted line that goes around like that. This is what it would look like over here. So this area at the top, the Bowman's capsule, the proximal convoluted, and the distal convoluted tubules are all found in this area, which is the cortex. And then the loop of Henle and the collecting ducts are found in this area, which is the medulla. Okay, so there's the medulla. And what is the purpose for that? Okay, I'm going to quickly just show you how amazing this actually is, and then I'll show you how it's regulated. So this area, the loop of Henle, is responsible for regulating salt. Okay? So, and I'm going to show you how salt is regulated. I just want to explain to you why it drops down into the medulla. So there's our salt. So what happens is here, a lot of salt gets reabsorbed into the blood. Salt is NaC out. And just like when you, for example, eat a very salty meal, salty chips or biltong or whatever, it stimulates thirst. And the reason for that is because salt draws out water. And so what happens is we have the salt being regulated in this medulla area, and that helps to allow us to conserve water. And so as the urine, which is now being produced and being transported, if you have a look at over here, that urine is coming down into these collecting ducts and is eventually going to be funneled into this part to get taken away. That contains water. And we don't necessarily want to lose all of that water. And so salt actually assists in the reabsorption of water. So the reason why that loop of Henle drops down into this medullary area is so that you can draw water out of our collecting ducts. So this is the collecting duct. That's where the collecting duct runs. Okay? Yes, everybody happy? We would absorb water because that loop of Henle has caused salt to be reabsorbed over here. Really smart, really cool. One of the things I absolutely love about the kidney. Okay, so now that we know why it's actually dropping down into the medulla, let's understand how salt is regulated. So I'm going to just remove this so that we can add some stuff onto here. So, salt is regulated by a hormone. That hormone is produced by a gland that's found on top of the kidney. So here's our kidney, found on top of the kidney. It almost acts like a little cap. You can see that, I don't know. There's a little, and that gland is called the adrenal. That's a D. Adrenal gland. Apologies for the handwriting. Adrenal gland. And the adrenal gland secretes a hormone that regulates salt. The name of that hormone is aldosterone. Aldosterone is secreted from the adrenal gland. And what aldosterone does is it gets transported in the blood to this area here at the collecting ducts. Sorry, not the collecting ducts, at the loop of Henle. Aldosterone acts on the ascending loop of Henle. In other words, the area that's coming up. Okay? Also, don't worry too much about that, just the loop of Henle. So this whole thing is called the loop of Henle. So at the loop of Henle, aldosterone comes. And what does aldosterone do? So aldosterone is produced from the adrenal gland, transported here, and aldosterone is acting in this area at the loop of Henle. What does it do? Well, it stimulates the active pumping of sodium ions, Na+, sodium ions, okay? And it's active, so it uses energy to do that. It's using a bit of energy in the form of ATP, so energy, ATP, and it actively pumps out Na+, okay? So it's forcing Na, sodium ions, to come from the loop of Henle into the blood. Remember, our blood is looping around here. Okay, I'm not adding it because of complexity, but the blood is here, there's a blood supply around the loop of Henle, and we're actively pumping the sodium ions out. Now, the thing about sodium ions, or sodium, is that sodium has a best friend. Sodium's best friend is chloride. Okay? So, sodium has a positive charge, Na+, and it passively draws out a negative ion called Cl-. Cl-. And that happens passively, so it doesn't require energy. Passive movement of Cl- out, also into the blood. So out of the tubule, into the blood, and together, NaCl is formed, which is salt. So that's how salt is actually regulated. And as I said to you guys, that salt then also draws out water from not only the collecting ducts, but also from the tubules around it. And water is then conserved. And I said it's almost like three best friends, okay? If I kick out one person, and I use the example of Kholo, if I kick Kholo out of the class, so I say, okay, Kholo, you're out, I actively tell her to get out. I push her out of the class. Her best friend, Anatita, is like, no, she's my best friend, I'm also going to go. And so she follows her. I didn't tell her to go, she just follows. And then the two of them are outside their friends. Their best friend is also missing out. Lilia, she wants to go, and she follows. She's water, she goes out and also follows. Happens all passive. So water movement is passive, the Cl movement is passive, the Na is the active. And what stimulates that specific movement is a hormone called aldosterone. And so aldosterone acts over here and it forces our sodium ions out. So grade 11s, that's the regulation of salt. Okay. The next video I'm going to do is regulation of pH.